Some people might have been like permanently delayed because of the rain, aka not getting into period 1 at all. However, quick heads up, there has been a challenge to faculty to be much more on top of, where did you just go? Huh. That's fun. Is that exciting? That's very exciting. Okay, well, he just gave up the ghost. Okay, but there has been a challenge to faculty to be much more purposeful with period 1, tardies and absences, etc. So just a heads up, that's a warning, because I need to be much more purposeful. And since I have my nice little iPad just chilling in my lap, I can be. So that's cool. Corey, give me a quick reason as to why. Give me a quick reason as to why you're late.
What?
Oh. Alright, kiddos. As you're opening your notes, you're on that last example from Friday. We didn't finish it. How do I know we didn't finish it? I know, I'm trying to get it up because it's not very happy this morning. I know we didn't finish it because it still had U's, right? So get rid of the U's. They should not stay in an answer with U substitution. We use them and then we get rid of them. True? Alright, we use them and then we get rid of them. So go ahead and finish up. Sorry, on the last page. Finish up this example, U substitution. It would be a good idea if you're like, yeah, I got kind of lost at the end of Friday. It'd be a great idea to go ahead and review that example. Oh, I'm already recording, I forgot. Yeah.
Are they allowed to use this type of, like, using the use for all the problems?
Yeah, basically.
Because in ProChat, they weren't doing that.
Do the directions ever say, like, do it the old school way and then use USEB? And they were doing problems with no U equals at all?
They had some where it was like, do it as like example 10 have U's, and then you have to solve for X. But the other ones, when they solved it, even that one, they didn't put U's, they didn't like identify what as well.
It might just be they're not showing work. Maybe they're just cheating. So please, 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 guys, for everyone, let this be a word to the wise. As always, CalcChat sometimes skips steps. It's kind of like if I had a CalcDC kid come in here and try to take this integral. Maybe not this one specifically. No, they probably could. They should be able to jump to this answer a lot quicker than you guys. And even not this one, they should have shown some work for certain, but other ones they would be able to mentally get to without showing any work. That's kind of what CalcChat's doing. The people who were making those answer keys were definitely at a level above you guys, not to at all diminish where you guys are at and what you're learning, etc. It's just they're probably grad students who are like, this is easy stuff. So please be careful that you don't use CalcChat as your guide as to the work you show. But the answers should still be matching up, and they should not be leaving things in terms of you. Okay. With all of that, let's go ahead and quickly write this answer because it's easy cheesy at this point. We've done all the work, kiddos, right? What's the last thing we had to do? Oh, I guess we could plug in U, right? But is there anything else that we're going to have to do? We could pull out U to the 3 halves, that's very true. And as we pull out U, oh my goodness, you are a huge pointer. Hold on, what's going on? Sorry, that was really awkward. Okay, let's try it now. You guys see the shared U to the 3 halves, right? What else can we do besides pull out U to the 3 halves? Do what? Oh, pull out a 2? Yeah, we can pull out a 2. So we have 2/4, and then we have, why am I going to put 3/15? And then 5/15. What am I getting? Common denominator. So I pulled out the 2, I pulled out the U to the 3 halves. Oh wait, I haven't shown that yet. That's okay. And then I'm getting common denominators because the AP guys love to pull out that fraction because they're like, ew, fractions make things complicated. When I pull out U to the 3 halves, I'm dividing this guy by U to the 3 halves and this guy by U to the 3 halves. This one cancels out, so he's totally gone. What happens to this one? What do we do with like bases when we're dividing? We're going to subtract. So we end up with U to the power of 2/2? What's that?
1.
Yeah, that's just U to the 1. So now what can I pull out that's in common? 1/15, right? So now I'm going to pull out a 1/15. I'm going to get 1/30. It's probably about time to be plugging in our u. Who was our u from up above, cool kids?
2x minus 1.
Yeah, 2x minus 1. So let's go ahead and plug in 2x minus 1. If I can get my cursor, there we go. 2x minus 1 to the 3 halves. I pulled out the 1/15, so now I just have 3 times 2x minus 1 to the 1 plus 5. Double check. Oh, again. We'll say it's the rain. The rain's messing everything. Alright, give me a sec. You guys go ahead and finish simplifying, because all we had to do now was, or all you had to do now, is combine like terms, right? Struggle. For my kiddos that came in late, what we're doing is finishing up that last example from Friday. You guys hated the second to the last. It was messy. I went off to the side of the board and everything. But then I was showing you one that was a bit more AP-ish, and that's the example that we're solving. We got down to the power rule for integration with u's. We were going to plug in terms of x, and then we're like, wait, but we can factor stuff. Alright, come on, buddy. Stay alive. And then hopefully you guys are noticing, I stopped him from connecting. There he goes. Hopefully you guys are noticing that you should end up looking a whole lot prettier than you did at the beginning, even with the u's, because we're getting rid of all those nasty fractions. He's alive. Well, I'm quick reason for being late. Okay, quick reason for being late.
Traffic.
Got it.
It a lot of rain.
Yeah, no, I'm tracking. Oh my goodness gracious. Okay, hold on, give me a sec. These guys stuff you guys can do while the iPad's deciding to work. It's connecting, it's just taking forever. He's right there. Okay, you're connected. Okay. Anyways, so I was unable and then it did. We'll just say praise the Lord. Okay, so you guys went ahead and hopefully distributed, and as you distributed, you get 6x minus 3 plus 5. 6x minus 3 plus 5 would be plus 2, right? 6x plus 2 plus c. 2x minus 1 to the 3 halves. 1/30, and you're like, yay, I'm done. What's the one last thing they would do? Yeah, pull out. Isn't there one more thing in common here? We have the 6 and the 2, so we can pull out a final 2. 2/30 would be 1/15. 2x minus 1 to the 3 halves. 3x plus 1 plus c. Now guys, I'm already warning you right now, if you want to highlight this problem, this is a great problem for the next test. Why am I saying that? Because if you guys were up here or up here, you would not necessarily have any clue that this is the only correct answer in the multiple choice problem unless you simplify. You would have gotten really, really lost, especially if you were still stuck at this top one and you just plugged in the 2x minus 1. That looks almost nothing like that bottom one for a lot of you. So please, 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 please realize they love getting common denominators, pulling out the fraction, pulling out the shared powers of u, and then making it look all nice and pretty and factored and simplified. That's what's going on here. Oh, because I pulled out, let me show you, I pulled out this common 2. And so that's how I got the 2/4, and that's how I reduced to 1/2. Does that make sense? Then I pulled out the 15, and that was 1/30. Yeah. Yeah.
How did, when you distributed the 3, did it go to plus 2?
Oh, because I had 6x, which stayed, right? Then I had minus 3, but I also had a plus 5. So I had to combine my terms. I did it fast. Any other questions about how I got there? Okay, if I were you, I would highlight it. I would start at this example. I tell you guys to study your notes, and yet some of you need to pull out some of these tricky examples that are kind of hard, and yet great, great, great ones to actually study. Now, I'm going to go ahead and give you what you guys can tell that this is totally my writing, right? This is what I say, how you should approach an integration problem. This is how I say you should approach an integration problem. And as you do the notes, I want us to think about, how would we do the example at hand, right? How would we do the example at hand? So write this down, literally, I want you to write it down because this gives you like a little game plan. Now, we're going to cover 2 more sections. This chapter is kind of like the second half of the chapter. It's chapter 4b, he has his own test. 3 sections put together with like an AP assignment, put together with like a worksheet. I'll probably finish our motion packet too, just to get it done. We might save that until later. But, even though the next 2 sections are going to add a couple more techniques, this is still how you start an integration problem. Number 1, can you do a direct rule right away? The answer will only be yes if it matches one of those basic rules that we learned in the beginning. If it matches one of those basic rules we learned in the beginning, and if the argument is just x alone. Not 2x, not x squared, not 3x minus 1. We can only do step 1 alone if we recognize a basic rule and if the argument is just x. So this one, secant tangent. Yep, it's a basic rule. The argument is just x. What is my final answer? Secant x plus c. Secant x plus c. So those reds don't match. It's kind of annoying. Let me pick a different color. How about red? If you're going to apply a direct rule right away, awesome, awesome. Get it? Don't forget your plus c. Go. Number 2. Try to simplify. I'm going to give a hint here. Try to simplify, but how? Try to simplify. This is review from section, I don't even know, 4.1? No. 4.3? Yeah, that sounds about right. Try to simplify. You can do this when you can multiply or divide. Mr. Clark has happy music this morning. Multiply or divide into a sum or a difference. Some of you are getting a little stuck on this idea. And you're making up product rules or you're making up quotient rules for integration, and they do not exist. Some of you are making up product rules or quotient rules for integration, and they do not exist. So when you look down at the next example, let me zoom in. When you look down at the next example, technically I suppose you could do a U sub. Guess what? It's going to end up being the exact same thing. There is no other way to solve this integral unless you say, hey, I can, what? I can distribute, remember factor is pulling out, distribute is putting in. I can distribute, make it a sum or difference, and then just use my simple sum or difference rules, aka take each piece, do it one at a time. But the only time I can do it one at a time is if I have a sum or difference. I cannot make up or use any sort of multiplication product rule that we have done in the past with derivatives. They are all illegal. But I can distribute, say, hey, it's a sum or difference. Okay, one piece at a time. What is the integral, the antiderivative, we could think, of x squared? X cubed divided by 3 or times 1/3. Same thing, right? How do I find the antiderivative of x? Good. Up that power. Divide by 2 or multiply by 1/2. And then I never forget mine, or else poor little red pandas are going to die. And once again, how can you always double check any antiderivative? Yeah, divide it. Bring down that 3, it cancels. Become a 2. Bring down the 2, it cancels. Make it a 1. Got it. U sub. U sub. U sub. What if we can't just multiply and make it all better? What if we can't just divide and make it all better? Well, what if it doesn't fit a direct rule? We try U sub. So kiddos, number 3. Based on what we've done last week, was it Thursday and Friday, I think, finishing today, homework due tomorrow? Who would you make you? Love it. If that's you, who's DU? Derivative of 5x is 5, derivative of 7 is 0, and then add a dx, remember? Then you would go ahead and do some stuff like, bless you, you could go ahead and solve for dx, right? Making sure that we're ready for even the hard problems. Some of you might just see it fits perfectly and plug in perfectly, either way. We end up with the integral of 5 over u squared times du all over 5. The 5s aren't even a problem, they go away. We are not going to integrate like that. How are we going to think about this guy? Instead of 1 over u squared? Exactly. U to the negative 2 du. We're going to add 1, u to the negative 1, make it a negative. Then we're going to plug back in our x. And that is one way of writing it. Or, let's see if I have space over there. Oh, I don't have space. Sorry, coming back. Remember, they could always make it the 1 over or the negative 1. The big old plus c. The plus c is not in the bottom. But any of these are, or I should say either of those are correct. Either of these are right. I'm going to try and get him out of the du spot for the next example. But you guys, go ahead and start on that next example. Hopefully you see who is your u. 5x sounds like a great idea. There we go. Now it's out of the way. You guys have started, keep going. Remember, the name of the game is plug and chug. The name of the game is how do we substitute? Yeah. That is one method. Yeah. That's what we're going to do too, technically. Right? Because we see our du over 5, and so when we go to plug in, we're going to have sine of u. We're going to substitute for dx. Be a little bit more clear. We'll substitute plugging into the dx spot. You can. That is one method. I have used it in the past. I found this one to be a bit more helpful for harder problems, so I try to just teach one system. If that's not wrong, it's just not my favorite. Wait, who has a derivative of sine? Cosine. Ooh, but derivative of cosine should have a negative. So I'm going to have negative 1/5 cosine of u plus c. Although some of you, many of you, might be able to make that final jump of, wait a minute, I know who u is. U is, sounds like bad grammar, but it's good math. Negative 1/5 cosine of 5x plus c. And last but not least, the third one. Just a couple of you might be trying to do a really good job and be like, wait, you can multiply or divide to get rid of stuff. You might say, yay, let's divide, and that's totally illegal. Upside down hearts are almost as bad as upside down crosses. They're not. But in math, it's kind of similar. Steer clear. You can only split up a common denominator to go to multiple terms in the numerator, not backwards. So we cannot divide. Okay, well actually we could. But not divide like that. If we wanted to divide, we'd have to do this whole long division-y thing and put the x here and put the x plus 3 here, which is kind of cool actually. Because then you can say x into x is 1, you can put the x plus 3, and then you do this little subtraction-y thing, and then you get a negative 3, and you could actually do negative 3 over x plus 3, and then be able to actually anti-derive. But that's only for some of you that are like, that's fun. Let me try that. The rest of us are like, whatever, who's you? No! I didn't do that part of math. Come back. As I fix them, you guys, u is x plus 3. Try to go the whole way. Ooh, maybe he'll come back. U is x plus 3. He's alive. See, how far can you go? What's bad when you try to plug in? The U goes in, the DU goes in, but who doesn't belong? Okay, we gotta go crazy. What do we do when we go crazy? We have the math. Go crazy with us. Who's x equal? If you have an extra x, say, hey, who are you, buddy? There he is. Coming, hopefully. Come on. Come on. Solve for x. He's u minus 3. Plug and chug. It's just a rough day. Aha. Then we plug and chug. Now, what on earth did that do? Just made everything awful. Unless you remember what I said a second ago. What can you legally split up? Numerators. You can split up upward hearts or even like 3 or 4 or 5 pronged hearts, but we can't split up upside down. What do I mean by split up? We could make it u minus 3 times u to the negative 1 and then bring it in, but for most of you it'd probably be easier mentally to just think of it as, oh, common denominators. This guy had an over u and this guy had an over u, so let's go ahead and think of these guys. Bless you. This would be the same thing as, who's u over u? 1. Okay, how do I anti-derive 1? Variable, which in this case is u. How do I anti-derive 3 over u? 3 times 1 over u, u to the negative 1 power rule will not work because it is an ln. So to give myself just a little bit more room, we'll do u minus 3 ln of u plus u. Then we say plug it in, plug it in. So we'll have x plus 3 minus 3 times, struggle, not enough room. There we go. 3 times ln of x plus 3. X plus 3 is a line that's sometimes above, sometimes below, so I have to keep the absolute value bars in. There is one kind of crazy thing they could do, but it's not all that exciting, sadly. Not in this one. But just to prepare you for other ones, this is an ln, and ln's have ln properties. They could also put that cubed up top. Either one is good. The 3 as a coefficient, or the power rule for logarithms, this is a pre-calc thing. They could make it a little cubed up there. Sorry, the line cut them off. Remember? Pre-calc, you can take him and bring him up, or you can take him and bring him down. Same thing. Then last but not least, what else can you use for integration at this point? Careful division, which actually includes long division, but we'll see that more in section 4.6. Multiplying by 1 creatively, every now and then is useful. Plugging in trig identities, you guys have seen that already with tangent squared. Who's he? I don't know. Oh, thank goodness he's secant squared minus 1. We can anti-derive that. Adding by 0 creatively. These kind of sound like t-proof things, huh? These could be helpful even for non-trig, but I'm kind of mostly talking about trig. I'm mostly talking about trig or rational functions. Watch out for trig, watch out for rational functions where you have like an f over a g. Sometimes he gets hard, as you guys saw up here in this example, where we couldn't deal with him the way he is, but once we got him reoriented, we could. Watch out for trig. Watch out for rational functions. Once again, as always, you can always derive and check. All right, there are just a couple more things in this section, and it's mostly, I think it's things, well, no. There's one main topic, and then there's one thing that you guys have seen before, and we'll just quickly address it. So one more topic, and then one quick review thing, I should say. One more topic. Definite integrals. So far, all we've practiced in class are indefinite integrals. Plus c, plus c, plus c, plus c, right? Get a function, we're done. Get an antiderivative function, we're done. Plus c, some more. So is there anything different when we do u sub? I can't talk, sorry. What's the answer? Is there anything different when you do u sub in definite intervals? And the answer is yes. And the answer is yes. You give me a second to get it down. You don't need to skip any lines. We're going to go straight to examples, but I want you guys to look at, on the left, everything's in terms of x, and on the right, everything's in terms of u. But what changed? Or you're going to pretend like you said traffic for your excuse. How about that? Okay. This time it works. Purpose. To be able to solve definite integrals with u sub without changing it back into terms of x. Should have been n and then 2 instead of n2. Either way. To perform u substitution and just keep the u substitution and never have to go back. And here's the reason why. With definite integrals, our purpose is justifying a numeric answer. Unless there's like some sort of variable in the bounds. You guys have seen that before with AP questions, like a k standing for a constant, blah, blah, blah. But as long as there are two numbers in the A and B spot, in that spot and in that spot, our goal is to get one number that stands for the actual area under his curve between those x values. Wait a minute, x values, so what kinds of bounds are these? X bounds. Why? Because remember, it's x within A to B. True? Then, how do we choose u for this guy over here? Hopefully, you guys have learned how to choose u to be the innermost, hence g of x. So what changes in the u sub? Well, it's going to be f of u, true. It's going to be du, that's true. But what else do you guys notice with the definite integrals that changed? The bounds. It's no longer just a and b. You have to figure out who is u of a, which is the same thing as g of a, and who is u of b. And what is the purpose? G of b. Because if we have a u here, and we have a u here, then we better have what kinds of bounds here? U bounds. We're doing all the substitution. Not just the function, but also the bounds. If we have a dx, we're going to have x bounds. If we have a du, we're going to have u bounds. It does not mean that you can't solve it as an indefinite integral, change it back into terms of x, and then use the old-fashioned bounds. You can do that. But we're trying to demonstrate how u sub for a definite integral technically needs u bounds. So, here's the example we'll try to probably end with. We might do one more example of u bounds tomorrow. It's a little thing in your homework, not a huge thing. And the other concept I was saying was review. I can kind of do as a homework help tomorrow as far as if you guys get stuck on a couple ideas about even and odd, but we've seen that before. You guys have struggled with it before. So evaluate both possible ways. In the olden days, we would say, hey, x bounds, keep it in terms of x. However, if you guys look at it, do we want to keep that in terms of x? I don't think so. What do you guys think? Who would you make u? Which one? X plus 1? Okay, let's go straight to the u sub and figure out how we're supposed to do this. So if we were to make u equal to x plus 1, hold on. I think I gave you an example that you cannot solve with the formulas that we know so far. Okay, never mind. Skip this page. We'll see this another day. Meaning, like, it can't even be in the section. It's a little bit illegal. Let's just go to this one. He's easier. I apologize. You would have needed to know how to do tangent inverse backwards, and we're just not ready for that. That's section 4.7. That's section 4.7. Let's just do this guy. Okay. He's our example. The nice thing is, oh my goodness, they already told us u, but wouldn't you guys have chosen him anyway? Good. So now what do we do? du. Yeah, it's negative 1 to 4. What's du? 0 minus 2. Right? Then we would solve for dx. We would get dx is equal to du over negative 2. We're going to plug that guy into there. We already have our u to plug into the other. What's new with the definite integral is we say, hey, what's going to be u at the top and u at the bottom? Where do we plug it in? Well, who is u, right? So then to find u of 4, all we got to do is 5 minus 2 times 4. 5 minus 8 is negative 3. And then 5 minus 2 times negative 1. 5 plus 3 is 8. Now here's where it gets a little weird. When we go to plug in, we are going to have the integral. We are going to have u to the 8 times du over negative 2. Ooh, I haven't anti-derived yet. I'm just plugging in. Remember? So it has an 8. Five plus 2?
Yeah, it's not 8, it's 7.
Oh, I did 7. That's sorry. I thought you meant the power was 7, and I got really confused. The power is 8. Got it. Now here's where it's weird. Guys, 4 was what bound? The top bound. So where's u of 4 going to go? The top. 1 was what bound? So where is the 1? Or, sorry, negative 1 was the bottom. Plugging in negative 1, where's that going to go? The bottom. Ew, do we like that? No. So we're going to go ahead and switch it, which is going to end up giving us a 1/2 on the outside. Then we can do it the nice way, because this was a negative, and then we went ahead and switched it to switch our bounds. But then at this point, we're good to go in terms of solving. Alright, cool kids, I'm going to go ahead and finish this example and post it online. As pre-cal comes in, you guys go out, it's checked in. Yeah, if there's anything at the front you guys haven't picked up, please go ahead and handle that. Sorry, that looks dirty. Bye guys, be on time tomorrow. Remember, I have to keep an eye out. I'll maybe forgive the first couple minutes, and that's about it. You rather you do it.
I will.
He's supposed to be ready tomorrow. My first one. Yeah, you did have to.
What? 6'4"? Crazy bad. Test file correction. Darn. Tomorrow. What the hell is on?
6.4 is only 6.5. Oh. So remember we had law signs and everything, which is nice, because those will be on the test as easy. Well, hopefully.